So there is a meme that we all know and love that 0 divided by 0 is undefined. And this is true. 0 divided by 0 is undefined. Why? Well, there's not one number that you can multiply 0 by to get 0. And what I mean by that is you can multiply any real number by 0 and get 0. So 0 times n equals 0 is true for all n in real. Right? For any other combination, there's only one answer or 0 answers, right? So if we have 3 times n equals 5, there exists a unique n that satisfies this, right? This is trivial, but we know this, right? If we have the numerator is non-zero and the denominator is 0, then there is no solution, right? So if we have 1 divided by 0, then we want 0 times n equals 1, and there does not exist an n that satisfies this. So this doesn't work. And the reason that we define 0 divided by 0 to be undefined, despite the fact that every possible n will work, is because we expect our elementary functions to have one canonical answer, right? So back in the example of 3 times n equals 5, there is exactly one answer that fits that. In the case of 1 divided by 0, there are no canonical answers that satisfy this. I mean, you can include infinity, and we often do think about 1 divided by 0 as infinity, right? Or negative 1 divided by 0, or negative 50 divided by 0 as negative infinity, right? But if you're looking for reals, right, there needs to be one answer. But what if we allow our division to be multi-valued? What happens? Well, let's take 0 divided by 0. We could allow 0 divided by 0, instead of equaling undefined, we could allow this to equal the set of real numbers. We can do that. We can define it that way. We no longer have division as a function, right? That maps to a single real output. No, now it maps to a set, right? That has more than one element. And we can allow division to accept inputs that are also have more than one element, right? So let's say we have 1, 2 divided by 3, say. Well, this is going to be just the set of all of the fractions you can form with this, right? You have 1/3 and you have 2/3, right? So we have one input that has more than one set element, and we have a second input that has one set element. So we have an output that has 2 set elements, right? That we can do that. You can see how we can define that. And if we had, if we had this, then we have two inputs, each with two set elements. So then our output set is going to have four elements, right? So we got 1/3, 2/3, and then we have 1/5 and 2/5. This makes sense. So what can we do with this? What happens when we extend what we're doing? Well, we know that 0 divided by 0, I guess we could notate it like this, right? So we've got the set with just the 0 element divided by the set with just the 0 element. This gives us the set of reals. Now, this resulting set has infinitely many elements. The initial inputs, the initial arguments, only had one set element each. So it's not strictly true that we just multiply the number of set elements to get the number of elements in the output, right? Sometimes if you divide two sets this way, you get, for example, all the reals. So, well, we can do set arithmetic on this, right? We can do the set minus 0. This is going to equal the reals. Set minus 0. So this is going to be all the reals without 0. So all the non-zero reals, right? We can do that. So 0 divided by 0 minus 0 is the reals without 0. Makes sense so far? Okay, well, what's an interesting thing we can do with this? Well, we know that any non-zero number in the denominator with a 0 in the numerator equals 0. Now, doesn't it? 0 divided by 5 is 0. 0 divided by 10 is 0. 0 divided by negative Graham's number is 0. So, 0 divided by 0 divided by 0 set minus 0 equals 0 divided by the set of reals without 0. And this, my friends, is 0. So 0 divided by 0 minus 0 is 0 when you allow division this way. Now, this bracket notation is a little clunky. So, as we saw in the thumbnail of our video here, we'll allow some collision of notation, some overloaded notation. We can do that. So if we simply have our old notation here without brackets, and we just happen to know by context that we're talking about multi-valued division, then 0 divided by 0 over 0 minus 0, with minus here being set subtraction, equals 0. Is that notation justified? I don't know. It's cheeky, but it makes a good clickbait thumbnail now, doesn't it? 猜你们懂this.